Alright, so the calculations for the Hardy-Weinberg Principle. So first of all, we have two important formulas. The first one is to get the allele frequency, which is P plus Q equals 1. In this case, P is the frequency of the dominant allele and Q the frequency of the recessive allele. And if we have, for example, P, we can just subtract Q by 1, so like 1 minus Q. And if you have Q, we can do the calculation of 1 minus P to get Q. Then the other important formula is this one, which is for the genotypic frequency, where P squared, which is the frequency of big A, is added by 2 times P times Q, which is the frequency of big A, little a, so that would be heterozygous, this would be homozygous dominant, and then plus Q squared, which is the frequency of little a, which would be homozygous recessive. And all of these one add up to 1. Alright, with these formulas in mind, let's do an example. Let's say, for example, 960 out of 1,000 express the dominant allele. The problem here is we always need to know the homozygous recessive individuals in a population. So that's pretty easy. We just need to subtract 960 from 1,000. What are we gonna do here? And that would be 40. So that means 40 are homozygous recessive. So that would be little a. So we can start with this one. First of all, we want to get Q squared. So just to remind you, Q squared is the frequency of little a. So to get this one, we have our 40. And we just need to divide the 40 by the total population size, which is 1,000. So that would be 0.04. If that worked. And then to get the Q, we just need to take the square root. So Q is the square root out of 0.04. In this case, it's easier, but if it's a harder number, you can just type it into the calculator. And in this case, we get 0.2. So now we have our Q, and we can use the formula P plus Q equals 1, and in this case we have Q, so we can just rearrange the formula so to find our P. So P would be 1 minus Q, which is in this case 0.2, and that would be 0.8. So now with our P, we can get P squared, so the frequency of big A. So we just need to square this one, and that would be 0.64 in this case. So if it's the other one, just use your calculator again. And now we have almost all our values we wanted to get. We just have to find 2pq, which is the frequency of big A, little a, so the genotypic frequency, that would be heterozygous. So we just need the formula P squared plus 2pq plus Q squared equals 1. And we have this one, which is 0.64. We have this one, which is, in this case up here, 0.04, and then all is equal 1. And we are looking for this one for 2pq. So we can just subtract by 0.64 and by 0.4, and that would be then our 2pq. And in this case, just to get it really correctly right, we have 1 minus 0.64 and then minus 0.04, and that would be 0.32. So we have all the values you wanted to find, so all the frequency numbers, and this one is what would be expected if the population wouldn't change over time. So if we would do these calculations in the next 10, 20 years, 30 years, and if these values would change, it would say that there is change in the population, evolutionary change, and yeah, that's it.